Good day everyone, welcome back to our continuation of our discussion on the topic permutation. Today we'll be discussing cyclic permutation and permutation of digits. Cyclic permutation. N different objects can be arranged in a circle round a table in n minus 1 factorial different ways. That means when we are trying to arrange a certain number of objects in a circular path or around a table, for instance, we can arrange it in n minus 1 factorial ways. That's if it's 7 objects, to be 7 minus 1, which is 6 factorial ways. Now, if the objects are fit in a ring which can be turned over, the number of arrangements will be n minus 1 factorial divided by 2. That is, if the ring can be turned over, it becomes n minus 1 factorial divided by 2. As an arrangement with the ring facing one way will be one of the arrangements with the ring turned over. Now, we have our very first example is from November 1992. It states that in how many ways can 8 boys be arranged around a circular table. Now, for our solution, we know that the arrangement in a circular table will be equals to n minus 1 factorial, which is equals to 8 minus 1 factorial, which is equals to 7 factorial, and 7 factorial is equals to 5040. We have another question from November 1999, and it states that a family of 7 is to be seated around the table. In how many ways can this be done if the father and the mother are to sit together? Now, for our solution, the father and mother sitting together gives us a kind of restriction to our question. But we also know that since the father and mother are sitting together, there is only 2 possible arrangements between them. That is, the father can be on the right and the mother on the left, and the mother being on the right and the father on the left. Now, the next assumption is since the father and mother are acting together, we'll be taking them as a single unit. So instead of 7, we'll be dealing with 6. Now, for the other set of people, we are left with five other people, then including our father and mother, which is a single unit, brings our total to 6. Now, arranging 6 people around the table, it will become 6 minus 1 factorial. So adding these factors together, our total number of arrangements will be equals to 2 times 6 minus 1 factorial, which is equals to 2 times 5 factorial, which is equals to 240. Our next question is from November 2000, and it states that in how many ways can 8 men be seated at a round table if 2 particular men refuse to sit together? Now, the way we are going to be approaching this question is we are going to be looking for the total number of arrangements without any restriction around the round table. Then we are going to be looking for the total number of arrangements if the 2 men are sitting together. Then we are going to be subtracting when the 2 men are sitting together from the total number of arrangements. This will give us our answer, which is when the 2 men are not sitting together. So normally 8 men sitting in a round table, the arrangement will be equals to 8 minus 1 factorial, which is equals to 7 factorial. And also for the 2 men sitting together, that's when the 2 men are acting as a single unit, we are going to be using 7, so it will be 7 minus 1 factorial. But also the 2 men can arrange themselves in 2 ways. So our total arrangement, if the 2 men are sitting together, it will be equals to 2 times 7 minus 1 factorial. Now, thus, for when the 2 men refuse to sit together, it will be equals to 7 factorial. That is when there is no restriction to our arrangement, minus 2 times 6 factorial. That is when the 2 men are sitting together, which will be equals to 5040 minus 1440, and subtracting to be equals to 3600 ways. Now, we are also going to be attempting some questions on permutation of digits. Now, for our very first question, it states that how many 4-digit number can be formed within the digit 1, 2, all the way to 9. That is from 1 to 9. If 1, repetitions are allowed, 2, repetitions are not allowed, and 3, the last digit must be even and repetitions are not allowed. Now, for our very first question, which is number 1 or high, when repetitions are allowed, the first digit can be any of the 9 digits. That is, the first digit can be from 1 to 9. The second digit is also 9 choices, since the second digit can be from 1 to 9. the third digit similarly, and the fourth digit similarly. Now the total arrangement in this scenario will be equals to 9 for the first digit times 9 for the second digit times 9 for the third digit times 9 for the fourth digit, which will be equals to 9 times 9 times 9 times 9, which is equals to 6,561. Now for the II, or the second part of the question, it said that repetitions are not allowed, which means if you choose a certain number for your first digit, you cannot choose it for the second, third, and fourth digits. So in this scenario, the first digit can be any of the 9 digits, but once you've selected one of them, you are only left with 8 digits. So the second digit can be any of the remaining 8 digits. The third digit can be any of the remaining 7 digits once you've removed 2 digits from the first and the second, and the fourth digit can be any of the remaining 6 digits. So your arrangement in this case will be 9 for the first digit times 8 for the second digit times 7 for the third digit times 6 for the last digit, which will be equals to 3,024. Alternatively, this is a simple permutation question of selecting 4 from a pool of 9. This can be written as 9 permutation 4, and 9 permutation 4 is equals to 9 factorial divided by 9 minus 4 factorial, which will then be equals to 9 factorial divided by 5 factorial, which will be equals to 9 times 8 times 7 times 6 times 5 factorial divided by 5 factorial. Our 5 factorial in our numerator and denominator is going to cancel out, so we'll be left with 9 times 8 times 7 times 6, which is 3,024, similar to the answer we got previously. For the third part of our question, the last digits must be even and the repetition are not allowed. Here the last digit must be even, and we have 4 even digits from 1 to 9. That's 2, 4, 6, and 8. Thus the last digit can only be one of these 4. Once the last digit has been filled, we have 8 digits left. The first digit can be any of these 8 digits. The second digit can be any of the 7 remaining digits after we've selected one for the first digit, and the third digit can be any of the remaining 6 digits. So our total arrangement in this case will be equals to 4, that's for our last digit, times 8 for our first digit, times 7 for our second digit, times 6 for our third digit, which will be equals to 1,344. Alternatively, for the last digit, we have 1 out of 4 possible numbers. This can be written as 4 permutation 1. For the remaining 3 digits, we have to choose 3 numbers from the possible 8 numbers which are left, which is also can be written as 8 permutation 3. So in this case, our total arrangement will be 4 permutation 1 times 8 permutation 3, which will be equals to 4 factorial divided by 4 minus 1 factorial times 8 factorial divided by 8 minus 3 factorial, which will be equals to 4 factorial divided by 3 factorial times 8 factorial divided by 5 factorial. Simplifying this further, that will be equals to 4 times 3 factorial divided by 3 factorial times 8 times 7 times 6 times 5 factorial divided by 5 factorial. The 3 factorial in our numerator and denominator will cancel out, and also the 5 factorial in our numerator and denominator will cancel out. We'll be left with 4 times 8 times 7 times 6, which is equals to 1,344, confirming our answer in both cases. Our final example states that how many numbers greater than 4,000 can be formed using some or all the digits 6, 5, 4, 3, and 2 without repetition. Now we have 5 digits and 4,000 is actually 4 digits. Now in any way we are going to be arranging this, as long as we are using the entire 5 digits, it is going to be greater than 4,000. So in our first part of our question, any combination that gives us 5 digits or any arrangement that is 5 digits will be greater than 4,000, and that will be 5 permutation 5, which will be equals to 5 factorial. Now the next part is if we are selecting 4 digits, because we know all 3 digits will be lesser than 4,000, but for the 4 digits to be greater than 4,000, it's either going to be starting with 6, 5, or 4, and the rest of the digits can be any of the other digits. For the first 3 digits, there's only 3 possible options, which is 6, 5, and 4. While for the remaining 3 digits, we can choose from the 4 numbers that are left, and this can be written as 4 permutation 3. So therefore our total arrangement will be equals to our arrangement when we can choose any of the 5 digits, and the second part, which is when we are using 4 digits. So this will be equals to 5 factorial, that's for the 5 digits, plus 3 times 4 permutation 3, that's for our possible 4 digits, which will be equals to 120 plus 3 times 24, which is equals to 192 numbers. So there are 192 numbers that we can form from those digits that are greater than 4,000. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out our Hidden Fact Further Mathematics textbook. You can get the hard copy in bookshops, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen. Thank you.